In the previous lecture, we discussed retrospective analysis, and we implemented the DFS function. We split our vertical set on three groups, but we didn't discuss how can the first player win as quickly as he can. First of all, we need to define new classes. This classes, the first class defines like it's just the leaves of our graph. Next is defines in the same way how we define general class, but with only this if there exists the edge that go to panel vertex, we just define these vectors like n1 and so on. Then there is a question how these classes are connected. So we need to prove this and this proves by mathematical induction. We prove base, that's obvious, I think, and then we get we just consider our vertex. This we suggest that we have this, then we consider vertex, and we need to, and we prove that this vertex belongs to class, bigger class, and that's it. We get that this hence there exists E that in this case we just union all our classes, or all these classes and these classes, and we get that we get general class defined like this. But the question is how can it help us to find winning strategy with minimal count of actions? So since we prove that there exist piles, two sequences, we get that in this class vertices on this class, I mean, if the first player start to play in these vertices, it means it requires no more than 2 E moves to lose. and that's it. So notice that we get this and this. We just defined it like this, and then we notice that we can define it like this, and then the minimum count of steps in the winning strategy C for each S that defined, so only the last level equals to 2e plus 1 if the first player minimizes the count of steps and the second player maximizes it. Why we need these conditions that first player need to minimize it and last player maximizes it? Because look at this example. It's really I think just consider a situation that this the second player make move to this vertex, to n1 n1 vertex. It means we the winning strategy was как бы сказать так, just 1 second, I think. So we can get this graph, but with the winning strategy, is defined like this. Like we just if we locate it in some vertex, we we can minimize count, but and the second player must maximize it to that that's it. Okay, that's it. I think this example is really really fine, but I think so that's it's time to read questions. Do you have any questions about this?
Yes. Can you just please briefly explain what is this theory about? Because so it's retrospective analysis, but what is the theory part about?
Theory part. We learn combinatorial games. We learn combinatorial games, and we need to understand how to win in these combinatorial games as quickly as we can, if we can win, if the first player can win in this kind of games where we have all information and we have and all the moves are determinant of two players. It means we can find the strategy. It means we can determine who wins, the first player or the second player. And in the previous part, we just свели, reduce all the combinatorial games to games on graph and show that in this graph we can win, but we didn't discuss how win quickly as we can. Okay, today we discuss how we can do this. We determine new classes, then we prove this interesting свойство, and when we prove it, we can conclude that P2 class is a class when the first player loses no more than 2 moves. If we didn't prove that, we can't assert that there is no more than 2 moves. Did you understand me? Have you understand
Yes, I
me?
understood. Yes, thank you.
Okay. Next is I did как next is notice note that the minimum count of steps in our winning strategy is equals to 2e plus 1 if we fix this. Okay, if the first player wins. Okay, it's logical that the first player minimizes the count of steps and the second player maximizes it. And here's example why is it true? Why no? To clearly understand what happens. We have this type of I think we have this type of edge, that, but but we didn't we determine that we that only only this kind of fight, but not too controversial. Okay, next what? Um, this example about about that the first player minimizes the count and the second maximizes. Okay, I don't know how to explain you more correctly, but I think it's enough. Okay, next implementation. Here is an implementation of the previous task. Here's new implementation. One second. Okay, according to definition, according to according to this, we need to understand how to find this strategy for every for each vertex in graph. Okay, we have we have to look at all the vertices. We have to look at all the vertices on all the children, and if we have tie vertex, we need to mark it. But we took mark it but we can't say nothing about this vertex because maybe there's exist this kind of vertex. It means that this vertex will be n. Okay, but if we do this, if we find our vertex, we can't return from this function because we find minimum vertex, and in this case we can find lower class, or lower class, which is lower class that is even. Okay, that's why we need to store all these values, and we need to store as we need to minimize the count of steps of the first player. We take minimum of the current and and children count, child count. Next. If we didn't find any p vertex, we need to look at this. Find either we find or not n vertices, and we need to take maximum. That means if we didn't find any p vertices, we need to look. We need to look, have we n vertices and get maximum of it. Okay, because it means here's the second player, and second player wants to what? Wants to maximize count of steps, and he maximizes it. Okay, but if he finds any d vertex, that means he can move, he can extend the game forever, and it means we need to support this boolean. So once again, if we find some pair, there is this some pair vertex. It means that this vertex is an e plus 1. We take minimum here. Okay. Else, if we have some d vertex, it means second player can extend the game forever, and we mark it like that. But we can we could live just with this case, because we just have already there, but I think it's clear to understand. And then if we haven't any d vertices, we just we just store this to p, we just store p to n max assigned by type v. Okay.
So a question.
Notice that
The winning player.
If we have located in leaf, that means it type v equals to null, and that is correct. Okay, your question.
So we have one node for each player, and the winner is the player that we reach first, or how do we determine who's the winner?
How do we determine who is the winner?
Yes, so on the graph, how do we represent a winner player?
Winner player. Okay. If if first player сейчас second I if we locate it in some we have many of initial states of our graph. If we locate it in some vertex that marked as n and 2e plus 1, that means we can win, the first player can win. For example, кстати, for example, this will be p null, p1, 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 and so on, p1, and for example, this vertex will be what? n1 and n2. Сейчас, 1 second, n2. Нет, сейчас. Ну, допустим, вот это. Допустим, suppose it's вот это. n2. Нет, n1. 2. And this will be n2. Because we can make step like this. We can make, and then we can нет, none 2, none 3, and then none 2, and so on. And if we locate it in some position that it's n, that means we can win, and we look that just that in this number, and that's it. Did I answer to your question?
Yeah, so N1 and N2 and P1, these are nodes on a graph, and there are edges between them.
No, we can imagine our game, our Wiffles game, or like this, like graph, and we just как сказать, we can imagine the game like graph, and we can determine initial states of the game. For example, if we have 1 and 1 stone, it means the first player wins, because it can go like this, move like this, and that's it. And the second player will lose. If initial states,
Okay, I understand.
if initial states like in P, the first player wants to extend the time of game, and he will move to maximum n. And here is maximum n. Ой, слишком много. Too much. For example, here. Нет. Here. Okay, he needs move like where? Like here. And then first player move. And then that's it. Okay. Did you understand?
Yes, thank you.
Okay. Так. Who have any questions about this? Maybe I made mistake somewhere, but I think it's not. Maybe you have questions.
And also, in a question, the initial states will be given in the question, right?
Once again, sorry.
Do we get the initial states of the players in the question, or?
We have only one initial state in our
Okay.
graph. Into our definition, where is it? we have only one initial state, and
Mm-hmm.
by the way, by the way, uh, as we since we in this game we have two initial state about policeman and bandit, we have to um, extend our graph. We have to make it very big in this type of questions, and that's why we need to use some heuristics to so so как
Yeah, like A star, right?
like a star, like this.
Okay, and one more question. Do we get the graph in the question, or we have to kind of find
Do we
the
get what?
nodes and
One
upon
second,
them?
once
Do we
again.
get the graph in the question, or we have to kind of build the graph out of the initial state that we have and the information?
Uh, uh-huh. Once again, you
Yeah, so for example, in the cockroach question, the input was a full graph that we had to study it.
cockroach
Is the
question.
case here?
What question once again?
The cockroach in the last semester.
In the last semester, cockroach. Okay, cockroach.
It
Uh-huh.
was about the what?
Uh, we haven't two players in this. It's not combinatorial game, but no, you can how can you interpret it like combinatorial game?
No, my question is, do we get the graph in the input, or we have to build the graph?
Mm. Mm-hmm. You have to build the graph, I think. Of course, we have to build the graph.
То
I
есть
already.
в условии вопроса вы пишете граф, или мы должны как-то устроить и ну, э,
Создать.
найти, какие у нас edges and vertices?
Да нет, там же просто граф надается, вводится граф, и потом проводятся ребра, и ты уже, исходя из твоего графа и ребер, ты ищешь максимальную клику.
Мгм. Понял, понял.
I have I did implement I implemented this problem. I today I send it to chart. I think if you got interest to this problem. Okay. Mm. Do you have any questions about this problem? About combinatorial games? Why we uh, learn the combinatorial games? Why does we learn? Why do we learn combinatorial games? No questions. It's this retrospective analysis uh, very useful in machine learning. In machine learning, and you if you uh, understood if you understand this uh, approach correctly, you in the future uh, you understood you will understand easier some topics. Okay, uh, I have an assistant, and where is it? Where is he? Where is my assistant? 1 second. Ага, окей. Так, окей. We can explore some combinatorial problems. I find in lead code it. Okay, here's так, okay. That problem calls like what? The first problem. Let me find it. Как же называлось-то? Сейчас. I lost it. Так. Вот. Can I win? Visual key. Okay, I found it. I found it. Who wants to solve this problem? This is very easy problem, but it's a little bit tricky. Okay, we have Alice and Bob, and they are choosing any x that is deleted of n and divisor of n, and replacing number by n minus x. And this is the problem you must uh, carefully consider all the cases and just output the number. Who wants to solve it?
Is this similar to the first game we had?
Mm, first game.
Which
You talk about the first game in recursion and dynamic programming recursion about matchsticks.
yes, about matchsticks.
Yes, it's similar, but there is a little trick, and carefully considering
Okay.
cases and
Don't you just need to find the modulus of 2? You take n divided by the, well, n modulus 2, sorry.
Mhm. Okay, you want or what? I don't understand. Sorry.
Sorry, so if n modulus 2 is equal to 0, then you return winner. And if not, then so yeah, you just return n modulus 2 is equal to 0. Because
Yes,
that's the winner.
yes. Can we do it or not?
Oh, well, I'm not by my computer right now, but if what I would suggest is just write um just write if n oh no, just write return n modulus 2 equals 0, and that will give you the winner. And if it's not the case, then the other person would have lost the game.
Okay. Next is what? Try to consider what happens in like we draw this array like like we draw like we drew and look at what you get. I didn't share you with my display. No, no, not this, not this. Uh, you have this type of strategy or this type of strategy. I uh, just right away and look at what you got. Okay, what you got in the first cal? The what is in the one? I think. Who wins if we have only one? Alice or Bob?
Alice.
Alice. If player cannot make a move, they lose the game. I think it's Bob or not. Bob. Bob wins because Alice can't make any move. Okay. both wins. Do you agree with me?
Yes, because it's strictly less than n. Didn't notice.
Okay. Okay, we have if we have 2 and equals to 2, it's clear that wins Alice, because Alice can move like this, and so that's it. In when n equals to 3, what happens? I can't see what you type.
Bob wins if its n is equal to 3.
Bob wins. Bob wins. Okay, next. I think. Okay, next what?
Bob always wins if n mod 2 gives you a value of 1. And Alice wins if n mod 2 gives you a value of 0. So if you
Okay,
check for n, okay,
it's
waiting.
it's it's great for it's great, but you have to prove it. Why is it true? Okay, answer like n plus 1 divided by 2. Yes, yes, but no, yes. Okay, I have already solved a long time ago, but you have to prove this, that it's true. Okay, you notice this, and it's как бы you can prove it by mathematical induction. Uh, you have a base already. I um, advise you to use mathematical induction. Okay, what cases we have? We have a base mathematical induction, and what will be cases? We have, suppose we have the sequence BAB, so on, and n is what? Uh, n is what? Okay, or even what we will do next. It's simple, I think. Okay, suppose n is odd. It means what? It means next n is odd. Yeah, suppose n is even, and next is what? Next n is odd. What it means?
I think it means the other player can divide by 1 after n dividing by n plus 1.
Okay, it means the first player can just sub -1 and get n. Okay, and we get that if this is a first player, we the first player will win because he made a step to p position. Okay. Okay, that's true. Next, n is even. Так, что такое even? Стойте, one second. Even. Четная же. Сейчас. Вот. Нечетная. Я что написал? Is odd. Okay, n plus 1 is odd. That means Alice wins. No, it means Bob wins. Because all of the steps, because all of dividers of n, is what? Is odd. And if we sub there, we get even always. Okay. That's why what? That's why all of the moves of Alice go to B, go to Bob. All of the moves of Alice go to B, and that's why Alice loses. Okay, and even I've already prove that we just sub one and that's it, and we make a move to Boris or to Bob Cal. Okay, there's existence of what? Of pickle, and there's each cal is n. Okay, do you understand? Так, I don't understand who solve it. Who suggests that we can make a step to one, we just sub? Okay, do you have any questions about this problem?
No, all understandable.
All understandable. Super. Okay. Next problem. Can I win? It's this problem is too tricky. It's tricky too. Bob wins. So and okay. Who can suggest how to solve it? Any thoughts about how to solve it? unlike matches problem, here we the count of matches, the count that matches can we take is decreases. And that's why this problem is medium, and that's why you need to как бы быть начеку. What type of game you have. Look, we have that, for example. Don't we need the p here? Yes, we need the p here because look at this. All is from is all just как сказать? The count of states. No, it's a combinatorial game, but the count of states, is very big because every initial state of graph меняется, changes. If we, for example, have heavens 1, 2, and 5, this will be another task. And we need придумывать, we need come up with new strategy, come up with different strategies.
What about DFS?
DFS, okay, DFS. What type of DFS? Do we need suggest the most stupid solution you can come up?
Doing every check manually.
Every check. What do you mean by every check?
Meaning counting the sum that we have manually. It's the stupidest, longest solution.
For what complexity? In what complexity? Time complexity. Maybe when we can improve the solution, but we need to suggest the most stupid solution to clearly understand what happens. What this kind of check in what complexity this kind of check work. Believe in what complexity does this kind of check work? Ну, this is как бы in many interview you suggest yes, 2 to the power in exponential complexity. Yes, that's it. It's an exponential complexity. That's no 2 to the power of 15. Is it nice? Yes, it's nice. Okay, it's nice. And how can we improve it? Can we improve this complexity? But no, this is not necessary 2 to the power of 15, it's what? E2, it's not too much. It's just about 30,000 ticks. It's very fast, but can you improve this type, this solution? You suggest just recursion that it reads through all the vertices, but can we do it faster? We need to make the mean selection to get 1000, 100. What do you mean by mean selection? You want to get mean always, or what? Or you want to поступать greedy, like the mean amount of numbers. Do you suggest greedy solution? Жадное. Greedy. Я спрашиваю, I ask you, do you suggest greedy solution? Or what? Using the pair. Need to make the mean selection. Yeah, I don't understand what is mean selection. Like the mean amount of numbers. If the desired number is a combination of numbers lesser than it, can we use bit masking? Yes, of course we can. How you want to use bit masking? Bit masking, it's kind of optimization. Consider all the possible subsets of 15. Okay, that's clear. That sum to up to 100. Okay. Okay, who can implement it? I think you already old for doing such thing. I will help you a lot. Jala or Ravishi. Is that what I think I like? I can speak, you can write, but you can write. Ravishi can write on lead code. I can turn off recording. Only I can cringe. Can make cringe. Who can implement it? Jalal, Yesha. Where did you go? what. I can turn off the recording.